Hi, myself Edvij. Welcome to a demo of Missio, built for Signoz Hackathon. So starting with, right now, a lot of incidents that happen in production do not need a chatbot on top of the traces that they receive and any guesses from AI. They need evidence. Missio is an agent remediation mission control system that turns a real production failure into a bounded human control draft fix. Here is a complete architecture. So starting with architecture, I would like to tell here why I chose Rust and why a TOI, which is a visually interactive inside the terminal. With growing popularity around the CLI based coding agents, we need a visually interactive stuff which helps the people to have a live incident remediation. So that's why Missio is a Rust terminal application with a special TUI for live incident remediation. So here, an instrumental checkout service exports open telemetry traces into a self-hosted Signoz deployment. Flag admits the incident. Missio, written in Rust, has no layer, queries Signoz, so resolves immutable source from GitHub, asks a rig agent. Rig agent here is nothing but a Rust native framework for agentic stuff to be built, as it is a completely Rust native TUI. So I chose a Rust native agentic framework. Now I open a severity 1 incident from an unlisted Slack channel. The spatial TUI acquires the signal, waits for signals indexing when necessary, builds a deterministic evidence bundle, and resolves the precise production revision. There is no hard-coded incident inside the interface. So why I not chose hard-coded stuff? Because see, this product will be eventually used in production, or people would like to use in their workplaces. So having hard-coded stuff in order to show demo for a hackathon doesn't make sense. So that's why I made sure that we are moving in a proper production direction rather than just for building a toy stuff here. So next, rig, which is an agent framework I'm calling as rig, the agent here receives only the evidence linked files. Its response is checked by Rust policy. It cannot edit unread files, workflow, secrets, or credentials. It cannot approve itself, and it cannot claim that test pass. So the proposed patch stops at the human boundary. Pressing P, I have two commands here. With pressing P, which reveals the external action, we can have a draft pull request, and by pressing Y, we are just authorizing that particular action. So GitHub credentials never enter the model context here. So GitHub returns a pull request URL and exact draft commit, and Missio starts polling until unless the CI succeeds. And after the CI succeeds, it's moved to the final stage of handoff, where Missio marks the mission complete, returns the real pull request receipt, and asks the operator to review, merge, and deploy to the repository's normal pipeline. The most important lesson was that observability must survive real operational timing. Signoz indexing can be delayed, which happen like sometimes. So Missio uses bounded acquisition instead of inventing evidence or failing immediately. Authority remains deterministic even when the AI is probabilistic. Missio was developed with assistance from Codex, which is powered by GPT 5.6, and the agentic framework here, which I was using the rig agent in this particular product, explicitly configured with open router model. Thank you so much for tuning to the demo.